This is a how-to video using your calculator, and this is coming up with a line of best fit or a regression line. Those are synonyms for each other. And we want to fit a regression line. There are other types of curves. There's curves that look like that are quite wavy. There's ones that are, well, just take my word for it. There's a bunch. But the first step here is to get the information into the calculator so that you can come up with, and here is a cubic reg that I have done in a previous life. But we want to come up with a what's known as a lin reg in calculator talk. So we need to do that. And let's go back over, and I'm going to clear the screen here. So your first step, and we'll actually have to go backwards just for a second. And you're going to need to be able to turn something on in your calculator that's not normally on when you buy it, so that you can get the coefficient of correlation. You'll need this throughout the course. So to get that, second catalog, and you scroll all the way down to diagnostics on. And this will turn on this feature. So I hit enter, and it says done. Alright, we've got it. Alright, here we go. Here's how you enter the X information and the Y information. And you will always have to do this for coming up with a curve of fit, or a regression curve, or a regression line. All we're worried about is a line right now. You go to Stat. You click on Edit. And here's L1 and L2. L1 is going to be the X information. They've given you years here. And you never put years actually in your calculator. Normally what I would have done, if this is your starting year, that's year 0, this is 1920, I would have made this problem a little bit easier for the student, but that's the way life is here in Course Compass. This would have been 20, this would have been 40, if this had been 0, 20, 40, 60, 80, because those are the years from the year 1900. Here they've managed to say how many groups of 10 years from 1900. Well, 2 times 10 is 20, 4 times 10 is 40. So they want you to use that system. So in any case, I put in 0, 2, 4, 6, 8. 2, 4, 6, 8. Then I come over here and I put in 48.7. I put in 51.0, or just plain old 51. 52.6. 53.8 and 54.8. If you've done some typing and you've made an error and you have one more, like 0, 2, 4, 6, 8, if you had not put in this 54.8, by the time we get around to looking at the regression line, which we're just about to do, you would get an error. the number here must be the same as the number here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're set. Stat. Calc. You're always going to be using, at least in chapter 1 here, for regression, for a line linreg. You hit enter, and you hit enter again. Alright, we have everything we need here to answer the first part of the equation. Here's y equals ax plus b. Well, a equals 0.75, so I would substitute it there. B equals 49.18. I substitute it there. So I look at these selections here, and, well, y equals 49.18. Well, no, that doesn't work here. If I substitute a in for that, and b in for that. 0.750x plus 49.18. Not a bad choice. Let's go look at the others. No, this one has a negative sign. That wouldn't work. And this one has them reversed. This one is 49.18 substituted into a. So it's math trickery here. When I substitute 0.750 or 0.75 into a, well, another way of saying 0.75 is 0.750, so that passes. 49, well, it fits. So I click on B, and I check answer. Well done. Coefficient of correlation to 3 decimal places. Well, that's what they're calling R here. So 3 decimal places, 1, 2, 3, and we look at the 4th decimal place, and since it's not something where we would round up, I change this to 0.985. Okay, and I check answer. Excellent. Is this regression line a good fit? The closer you are, and really you don't look at R when this is a math lab thing. A better measurement is looking at R squared, and when I'm in the classroom, that's what I tell people. But the closer you are to 1, 0.971, that's pretty close to 1. You're only 3/100ths off. If R squared would have been like 0.1 instead of 0.9, it was 0.1, and it's very close to 0, that's an awful fit. So right now, 0.97, 3/100ths away from 1.00. That's a very good fit. So check answer. Nice work. Okay, the life expectancy in the year 2010, rounded to 1 decimal place, is... So, this is what we're using right here. Y equals 0.750x plus 0.4918. So what I want to do to go through this piece of this is now since we have the equation of best fit, we're going to use dirty old algebra to figure out what this is going to be. So let me cut over here to actually working out the rest of this on a pad of paper, and I have written down the equation. So looking back at what they're asking right now, they are asking for the life expectancy in the year 2010. And if you remember from the problem, years were the x-coordinate. So we're going to be substituting somehow into here to find out what the life expectancy is over here. So what do we put in here? Well, x is in number of decades, as I mentioned at the beginning of this problem. So how do you calculate decades? Our starting spot was 1900. So we're going to subtract 1900 here. And that's going to be, what, 110? Is that right? And 110 divided by 10 is equal to 11. So we're almost done here. Actually, we are pretty done. All that needs to be done, I thought we said we're done. In any case, let's do just one more step. Is to substitute this 11 into x here. And this is where I'm about to stop. Y is equal to 0.75 times 11 plus 49.18. And if I was a real nice guy, I would finish this. But I'm not a real nice guy. So I'm going to let you do this last step to figure out what y is, which is the life expectancy. You would put that into good old MATLAB or Course Compass, depending on how you view this, and hit that check answer button. And I think we can conclude this video.